Welcome to maths class. Today we're going to look at maximum and minimum problems. So these are problems when we are asked to find a maximum or minimum value for a variable. And these really are very common standard questions that we all need to know how to solve. So one of the things that you look for in the question, the first key really is identifying that you've got a maximum and minimum problem. And so you look for words meaning max or min, such as smallest, largest, and so on. And what we are looking for, you must remember, is the absolute max and min. Now we've just learned how to find absolute max and min. And one of the key things we're going to do today is learn how to go from a worded problem in order to find our equation, which we can then use to maximize or minimize. Some typical examples might be a maximum volume of a box, a minimum surface area, a minimum or maximum area, a minimum or maximum distance. So what we need to be able to do is write an equation for the variable to be minimized or maximized in terms of one other variable. So that might be, if we have a cylinder, minimizing the surface area in terms of the radius, for example. So what we need to do in order to do that is, first of all, we draw a diagram, and then we label it with as few variables as possible. In the example I just described, we'll have a height as well as a radius, but there might be some other information in the question that lets us write the height in terms of the radius. Then what we need to do is use any knowledge of measurement that we have. This includes Pythagoras' theorem and similar figures in order to try and connect different variables. So we draw our diagram, we label it, and from that we want to write an equation. So we're going to start by looking at one worked example. What we're going to do is find the minimum distance from the straight line with the equation y equals x minus 4 to the point 1, 1. I'm going to work through these steps as I go. My first step is to draw a diagram. My second step, write a function. Third, I'll need to differentiate that function. And then 4, I need to solve the derivative equals 0 in order to find my stationary points. Fifth, I'm going to check my stationary points, and if it's appropriate, I might also check endpoints. And finally, I'm going to answer the question. Never forget that last step. Always go back and double check what the question is asking. So in this example, I need to find the minimum distance from this line to this point. So I know how to draw this. So let's draw a graph of this line. I've got y equals x minus 4. So that's a straight line with a gradient of 1, and it's going to go through the points 4, 0, and 0 minus 4. And the point 1, 1. Put it about there. Now I need the minimum distance from the straight line to this point. So I'm going to just draw a line to this point, and I'm going to choose to call this point here Q. All right. Now Q is the point with an x value of x. Therefore the y value is going to be x minus 4. Now I need to find the distance between this point here and Q. So what I need to do is write a function for the variable that is to be minimized. The thing I want to minimize is the distance, right? So here are my clues. Minimum distance. I need to find a minimum of the distance, so I need d in terms of something. So if d is distance, I know that on the Cartesian plane, to find the distance between 2 points, I've got the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, this is from Pythagoras' theorem, but I learnt this in year 9, this equation. So, what have I got? I'm going from this point here to this point here. So this is x1 and this is x2. And I'll go the other way around. This is x1 and this is x2. So I've got x minus 1 all squared plus x minus 4 minus 1. This is y2 minus y1 all squared, which gives me this equation. Oops, sorry, you can't see that. Now I'm going to expand this and simplify it and see what it gets me. I can leave it like this, but if I'm going to differentiate, it's easier for me if I expand it first. So here I'm going to get x squared minus 2x plus 1, and I add that to x squared minus 10x plus 25, which gives me the square root of x squared plus x squared minus 2x minus 10x, that's minus 12x, and plus 1 plus 25, that's plus 26. Now I do have a common factor of 2, but taking it out is really at this stage not going to help me any. If I had a common factor of 4, that would be different because I could take it out of the square root, but I don't. So I'm just going to leave it as it is. So that's my first step. I've written a function, and what I've done is I don't have it in terms of x and y. I've got it only in terms of x, where x is the x value of this point Q, which is this line. Now what I want to do is make this line as short as possible. Q could be up here. Right, there's Q, or Q could be down here. There's Q. Obviously this value of Q is going to give me, this point Q is going to give me a different distance than this one. I want the distance to be the shortest possible, so I'm going to differentiate this in order to try and find the minimum value of D with respect to X. So that brings me to step 3, differentiate. I need to find D, let's call this capital D, dd dx. Okay, I've got a composite function because it's the square root of a quadratic function. So I need to find the derivative of the inside function. That's going to be 4x minus 12. Don't forget your brackets. Multiplied by the derivative of the outside function. The outside function is the square root of u. The derivative of that is 1 over 2 square root u. But instead of u, I'm going to write 2x squared minus 12x plus 26. All right, I can simplify this. There's a 2 there and a common factor of 2 here. So that's going to give me 2x minus 6 over the square root of 2x squared minus 12x plus 26. I have now found the derivative, of the function. My next step, solve for the derivative equals 0. So I've got dd dx equals 2x minus 6. I'm just transcribing onto my fresh sheet of paper. 2x squared minus 12x plus 26. So I need this to equal 0. dd dx equals 0 for stationary points. I'm always going to jot that down as part of my working. Why am I making it equal to 0? To find stationary points. So 0 equals 2x minus 6 over the square root of 2x squared minus 12x plus 26. Whenever I'm dealing with a fraction equaling 0, I don't look to my denominator. I don't want the denominator to be equal to 0, only the numerator. So really I need to solve 2x minus 6 equals 0, which gives me x equals 3. Now at this stage, it's not a bad idea to go back to my original diagram, because in this case, I can locate what I've just found on my diagram. There's 4, there's 1, 3 is somewhere there. So this is going to give me an x value of 3 is going to give me a point Q somewhere there. That actually looks pretty good to me in terms of finding the shortest distance between this point and this line. So I'm feeling confident in what I've done. Now, this is not any kind of proof that I've found the right answer, but it's always good when you can double check what you're doing, check that the numbers that you've found make sense. So I found a value of x which gives me a stationary point on the equation that I found for distance. Here's my distance equation, right? I know a stationary point. I don't know what kind of stationary point it is. So let's just do a quick check. I'm going to look at my point of 3. I'm going to look just to the right and just to the left of it. So when I put that back into my original equation, which is 2x squared minus 12x plus 26, my value of 3 is going to give me a derivative of 0, which gives me this. My value of 2 is going to give me 4, we're looking at this, sorry. It's going to give me, 8 here, minus 24, plus 26. Hang on. So what I'm going to do now is just check what kind of stationary point I have here at x equals 3. So I need to substitute the value of x equals 3 and a number just to the left and just to the right of it into the derivative to see whether to the left I have a positive or negative derivative and to the right I have a positive or negative derivative. So when I put 3 in, I'm going to get 0 because I just solved that x equals 3 will give me 0. This is my equation. Sorry, it should have a dd dx here rather than a 0, but that's the equation I need to substitute into. Okay, now when I put a value of 2 in, let's just check that I get a positive number under my square root. This is going to be 8 minus 24 plus 26. That's going to give me a positive answer under my square root. So what will my numerator give me? 2 times 2 is 4 minus 6. That's a negative number on my numerator. It's going to be negative 2. Now, that's not the actual value, negative 2. That's just my numerator. The point is, this is going to give me a positive number. So what will this give me? It gives me a negative number, which means my slope looks like this. Now, if I put 4 on my denominator and I check that, I will also get a positive number under the square root. So let's check what I get in the numerator. 2 4s are 8, subtract 6 gives me a positive number, which means my slope looks like that. Therefore, D is a minimum at x equals 3. I can see that. I've shown that it's going to be a minimum. I don't need to sketch the graph. So I've drawn my diagram, written a function, I differentiated, I solved it for dd dx equals 0. I checked my stationary points. Now the x, there's no end points here, all right? But my stationary point gives me a minimum value. Now I need to answer the question. So what was the question? Find the minimum distance, right? It doesn't ask for x, it wants the distance. So I now need to put x equals 3 back into my original equation. My original equation was d equals the square root of 2x squared minus 12x plus 26. So that gives me 2 times 9 minus 12 times 3 plus 26. Here's one I did earlier. What did I get? Root 8, which is 2 root 2. Leaving it as an exact value because I wasn't told otherwise. Okay, so let's just make sure we've answered the question. The minimum distance is 2 root 2. Follow the steps. Now I really should add one step at the beginning because before I start doing this, I really need to identify that I've got a max or min problem. And some of the errors I've seen in the past are where students have not managed to do that step. Once you've identified that you've got a max or min problem, by looking for words like maximize, minimize, the smallest possible, the largest, etc. Then we follow these steps. Don't forget step 6, double check what is the question asking. Okay, there will be more worked examples in another video.